Hello, and wow, that was such a bright. Uh, Stomach also says hello, hello. Welcome to another nostalgic ramble. We are looking at IEB's November 2023 paper 2. Question 2. Sometimes these other personalities just come over me and I just watch in disbelief as I say things that it's not what I'm saying, but it's how I'm saying them. It's just so question mark. Anyway, right, question 10, let's go. In the diagram, A, C, and D lie on the circle with center O. Love me some centers. Centers spells radii, spells diameter, spells angle at center, spells maybe sometimes perpendicular line to chord through this, all the good things. Right, and A, C, and D are on the circumference, good to know. AE and DE are tangents to the circle at A and D respectively. So these guys are tangents, radii, tan rad, right, but of course at equal tangents, right, meeting at one point is coming to mind. There might be opportunities for tan chord, right? So tangents, keywords we love to see. ACD is 68 degrees. ACD. Okay, so that angle over there. Fill that in for ourselves. Okay, right. Thank you. And then, of course, state all relevant reasons with whatever statements you make. Prove that AODE is a cyclic quadrilateral. So if you imagine a big circle passing through all those 4 points, yeah, pretty much prove that there is a circle that passes through all those 4 points. Anyway, so yes, we need to show that AODE is a cyclic quad, and with proving that something is a cyclic quad, it's one of two things, right? You are either proving that this angle and this angle are supplementary, or this angle and this angle are supplementary. Okay, I'm already seeing right, because we know that that's a 90 and that's a 90, so a cyclic quad for sure. But anyway, just to complete my train of thought, the alternative would be to show that, or the alternatives would be to show that an exterior angle is equal to the opposite interior one. So for instance, this angle is equal to opposite interior. Opposite interior just means, okay, come in and then across, so equal to that one, which is also easy to show, and likewise show that this is equal to that. We don't have the exterior angle that would be opposite to this one, right? Because that would be go across there. Yeah, it would be if there was a line going this way, that angle would be opposite to that one, and opposite to this one would be, okay, go across, extend this line. If we had an exterior angle there, it would be opposite to that one. Anyway, so those are all the different ways that you could go about showing that AODE is a cyclic quad. But as you've already identified, the one that is available to us right from the jump is that these two are each 90 degrees angle and therefore supplementary. So let's go. So we first have to say OA and O. Do we? We don't really have to. In fact, we really don't have to. What we can do is go straight to saying angle A1 is 90 degrees, and then here in your reason you can indicate tangent AE is perpendicular to the radius OA, and then angle D3, So we've got this is 90, D3 is also 90, and the reason for that is the tangent DE is perpendicular to the radius OD. Right, and so then, therefore, A1, well, okay, what do I want to say here? So we would then say, therefore, AODE is a cyclic quad. Reason being, opposite interior angles A1 and D3 are supplementary, as in they add up to 180. Right. Okay. Cool. Nice. So, on to the next question. Just going to start by filling in what we know. We told this is 68. We have figured out that these are 90 and 90. I don't know if it's going to be useful, but I mean, I guess it probably will be, but we now know that there is a circle that exists that goes through the points A, O, D, and E. Okay, right. So, the next question asks us to determine the size of E. My goodness, this is not hard. which is good. Okay, and I also shouldn't, okay, please note that whenever I say something's easy, something's hard, all these things are ultimately subjective, right? Especially in a space like geometry, where sometimes you just see something straight away, whereas someone else might not see it, or so yeah, I do not say easy or hard or whatever to patronize anyone or to explanation. Anyway, so this is easy because I immediately see that, well, we have our angle at center here, and its matching angle at circumference, so we can figure that out. And then, whether you use the fact that it's a cyclic quad, AOD is a cyclic quad, or you can just use angle sum of a quadrilateral, because we know the angles of a quadrilateral add up to 360 degrees. So if I know what this is, I know these are 90, then I can figure out what that is. So yeah, let's go. Angle O2 is equal to 2 times angle C, because of angle at center. So that would be 2 times 68 degrees, which is 136 degrees, right? And then I'll use the fact that AOD is a cyclic quad to say angle E is equal to 180 degrees minus angle O2, reason being opposite interior angles of cyclic quad AODE. Right, so that will be 180 degrees minus 136 degrees, which is 44 degrees. And yeah, we have E. So let's see what the memo has to say for itself. Yeah, very short in the memo as well. So for the first question, they went about it exactly the same way that we have now. And for the second question, also the same approach. So yeah, I think the key thing is, as you start reading the information in the question, when you see center O, I think, I've made a video about this, think radii, think diameters, think angle at center, think perp line through center, right? Those kinds of things. See if those relationships you can spot straight away. Next point tells us about tangents. What are your theorems related to tangents? Do you see any of those relationships, right? And then ACD is equal to 68. Well, okay, that is just what it is. In that way, you're opening your mind up, right? So that when we now get to the actual question, you kind of have a sense of the tools, the things that you can try out first. So yeah, I'd recommend you check out the video that I made just showing you my summary, my little cheat sheet of theorems, how I group them so that I'm able to easily recall them depending on what information is provided to me in a question. Cool. I think I should, yeah, I will add that as a card somewhere here. Cool beans. See you in another video for another question.